Today, we're going to look at lines parallel to the x-axis and y-axis, or equations in one variable. Let us look at the Cartesian plane. Let us look at the y-axis. So the origin lies on the y-axis. The points 0, 1, 0, 2, 0, -1, 0, -2, 0, -3 all lie on the y-axis. Do you notice that the y-coordinate in all these points is changing, whereas the x-coordinate is staying constant at x equals 0? It is interesting to note that x equals 0 is the y-axis itself. X equals 0 is an equation in one variable. Let us look at another line, this time a line parallel to the y-axis. We see that the line intersects the x-axis at x equals 2. Let us look at the points lying on this line. Once again, note that the y-coordinate is varying, whereas the x-coordinate is staying constant at 2. In fact, x equals 2 represents this line parallel to the y-axis. Recall that in previous lessons we saw that x equals 2 represents a point on the x-axis. In fact, it is a point on the number line. So x equals 2 is a line in the Cartesian plane and it is a point on the number line. Let us look at a few problems. Express y equals 3 in the form ax plus by plus c equals 0. Note that we need a 0 on the right hand side. So let us subtract 3 from both sides of our equation. We get y minus 3 equals 0. Now we also need a term with the variable x. We could multiply it with 0. So we get 0 times x plus y minus 3 equals 0. We can put 1 as the coefficient for y, so that its value remains unchanged. Now let us compare this with the form ax plus by plus c equals 0. We see that a equals 0, b equals 1 and c equals minus 3. How do you think y equals 3 will look on the Cartesian plane? Let us plot y equals 3 on the y-axis. Now recall that an equation in one variable is a line either parallel to the x-axis or the y-axis. Now from this point y equals 3, we can easily draw a line parallel to the x-axis. Why does this make sense? Because as we move on either side of point A, we see that the value of x is changing, whereas the value of y remains constant at 3. Let us look at another problem. Give the geometric representation of 2x plus 5 equals 0 as an equation in one variable and in two variables. Let us look at our equation. We can write it as 2x equals minus 5 or x equals minus 2.5. Now we have to represent this in one variable. One variable can be represented on the number line. So let us plot point A equals minus 2.5 on the x-axis. Now this is the representation of this equation in one variable. What will change when we represent this in two variables? Yes, we would be plotting this in the Cartesian plane. And in the Cartesian plane, we are also looking at another variable called y. Now we know that an equation in two variables represents a straight line. So x equals minus 2.5 has to be a straight line crossing from the point A. Now the value of y can change, but the value of x has to remain constant. So it shall be a line parallel to the y-axis. Note that as we move on either side of point A, upwards or downwards, the value of y variable changes, whereas the value of x variable remains constant. Let us look at another problem. Identify the lines drawn in the given figure. Identify another line passing through the point of intersection. Let us look at these lines one by one. Let us first look at the line parallel to the x-axis. We see that it is intersecting the y-axis at -4. So the value for y is going to remain constant and the value for x is going to change on this line. So y equals -4 is the line parallel to x-axis in this figure. Now let us look at the line parallel to the y-axis. We see that it is intersecting the x-axis at x equals 3. Now as we move on this line, we see that the value of y is going to change, whereas the value for x is going to remain constant. So x equals 3 is the line parallel to y-axis in this given figure. Now the point of intersection of these two lines would be x equals 3 and y equals -4. So we can write point E as 3, -4. Now we have to find another line passing through this point E. So let us write x plus y and substitute the coordinates of point E. So we get 3 plus -4, which is equal to -1. So x plus y equals -1 is a straight line that passes through the point E. Instead of x plus y, we could have also tried x minus y or minus x plus y or 2x plus y or any other coefficients for x and y that you like, and substituted the value for x and y from point E.